discuss numerical on the IPV4 header. Many times, numerical on the basis on the format of IPV4 is asked in the university examination as well as in competitive examination. So that is very important. How to solve numericals on the IPV4 header format. Okay. In the last class, we have discussed the IPV4 header format, in which we have seen where the minimum 20 byte size of IPv4 header, and it may be maximum of 60 byte also, because 40 byte option is also there. It may or may not. It may present or may not. If it present of 40 byte, then certainly the header length will be 20 plus 40 or 60 bytes. Okay. There are the 5 rows that are compulsory. We have seen each row of 32 bit, or we can say that 4 byte. So all these are discussed in the previous. Let us just we see at a glance all that particular fields. So first field was the version, and in IPv4 case that consists of value 4. Okay. And then header length, that is of 4 byte, 4 bits actually, 4 bits. So certainly that can consist of how many byte? How many? If this is of 4 bits, how many bits? 4 bits header length. So what will be the total length? Certainly that may be 0 to 2 power 4, means 0 to 15. 16. This is the maximum length that may be represented by the 4 bit. So 16 byte only can be represented by the 4 bit. So here is the concept of scaling factor. Okay, because we know that minimum size of header is of 20 byte. Okay, and maximum is of 60 byte. 60 byte. This is the maximum header length. So that cannot be represented by this 4 bit, no? Because by using 4 bit only 16 byte can be represented. So here is the concept of scaling factor, that is the 4 here. That means what is the value in the header length that is multiplied by the 4, because when we multiply this 15 by the 4, the value will be 60. Okay, that means the maximum number that can be represented by the 4 bit is the all 4 bit set, that is the 15. Okay, so in this case maximum size will be 15 only. So here there is a scaling factor known as 4, and that is multiplied by the value of this header length, and that gives the actual length of the header. Okay. So as we know that minimum header length is the 20 byte and maximum is the 60 byte. Okay. So actual header length is the header length field value multiplied 4. Okay, this 4 is known as the scaling factor. So whenever we have the value in the header length, we take that, convert in decimal, and then multiply by 4. For what purpose? To answer the exact header length. For example, if header length field contains decimal value 5, that means this one, in binary 4-bit representation 0101. So in that case, you cannot say that the value of header length is 5 only. No, we have to multiply by the 4. Scaling factor 5 into 4 is equal to 20 byte. So what is the length of header for this value? That is the 20 byte. Okay. Similarly, if the header field contains Decimal value 15 means all 4 bits are set. This value. That is the 15 now? Yes, this is the 15. So what is the actual header length? 15 multiplied by 4 scaling factor, that is the 60. So this is the actual length of the header. Okay, for the packet which have the header length field as 15 decimal value. Then the service type, okay, and the total length will be length of data. Yes, this is very important. Many times length of data is asked in the examination. What is the length of data? So how we calculate the length of data? So we have the idea of total length because there is a field of total length. So we convert that field into decimal, and then that decimal value gives the total length. And in total length, from total length, we have to minus the header length. Header length. Okay, so that will give the data length. What is the data length? Okay. Then is the identification, flag, and fragmentation offset. All these are for fragmentation when the data is fragmented into number of parts. Okay. So basically, the flag consists of 3 bits. First is null bit, that is reserved, and always have the 0 value. The second bit is the don't fragment, also known as DF, and the third flag is more fragment, known as MF. Okay. Then the fragment offset. This represents the number of data bytes ahead of the particular fragment in particular datagram. To frame this fragment offset of 13 bits represent the how many data bytes are ahead from this current fragment. Okay. Then time to live, that has a numeric value. Suppose time to live for a particular packet TTL, in short TTL, this is the time to live, value is 4. What does it mean? It means this packet in worst case can be delivered by 4 hops. 4 hops. That means that can be delivered to the destination by jumping of 4 routers meanwhile. And after 4 routers, if it is not succeed to deliver at particular destination, then that packet is destroyed or discarded at all. Okay. For example, suppose there is a router. This is the router. This is the router. And this is the other router. Okay. And here, this is the source. Here, there is a destination. Okay, these are the routers. And suppose a packet, this is the packet with, TTL value as 4. TTL value as 2, suppose 2. This is transmitted from source to destination. So when this packet comes to a particular router, the router decrement the value of this TTL. Then that comes to the other router also decrement the current value by 1. So suppose this particular packet comes this router. So TTL value at this will be 1. That means after 1 hop, this must be delivered to the destination, otherwise this will be discarded. If it is possible to deliver with 1 hop to the destination, then okay, otherwise this is discarded. So again, suppose this is transmitted toward the destination at this particular router, so the TTL value will be 0. Here 2 minus 1 will be 1, and here 1 minus 1 will be 0. So when this particular router, suppose R, come to know that now the time to live field of this particular packet is 0, that means, and this particular router is now the destination actually, then that particular router discard the value, discard the packet, so that that cannot unnecessarily move in the network and create the jam. Then protocol TCP, in TCP/IP, the data section of a packet called payload carries the whole packet from another protocol. A datagram, for example, can carry a packet belonging to any transport layer protocol such as UDP or TCP. Okay, so this protocol specifies which type of data of which type of protocol is carried by this datagram. The header section that check whether there is error in the header or not. Then source and destination address of 32 bit each. Then option may be there or may not. Then payload. Type of services, if this 4 bit is of 000, this is the normal default service. If this is the 001, minimize the cost. That means this packet should be delivered from source to destination with minimum cost. This is the maximized throughput. This is for maximized reliability. This is for the minimized delay. Okay, this is the type of service that is required for that particular packet during transmission. So let us see an example. Okay, because in this lecture I want to discuss the example, the numerical that come on the basis of this IPv4 header format. Okay, so this is an IPv4 datagram has arrived with the following information in the header, and this information is given in the hexadecimal form. Okay, and you have to answer these questions. What is the header size? Are there any options? Option means option field carry some information, some data or not. Is the packet fragmented? What is the size of the data? How many more router can the packet travel? This is decided by the TTL. Okay, if TTL value is 3, that means 3 more router can be traveled by this packet. Okay, you can say that this packet may travel 3 more routers. What is the identification number of the packet? What is the type of service? What is the destination IP address? Is the packet corrupted? Why? All these data, all these questions may be arrived on the basis of this state. Let us see. So, what is the first step? First step is we have to arrange these hexadecimal value in the datagram format. So, for this we have a very clear idea about the datagram format. Like we see, these are in hexadecimal. Hexadecimal means each symbol is of 4 bits. Hexadecimal means each symbol is of 4 bits. You know that. So that first 4 bit and first symbol is given in the version field, because version field consists of first 4 bit. So first symbol come here. Next header length is of 4 bit. So 5 is there, because 5 is also of 4 bit. 5 in hexadecimal. When we talk about in decimal, in binary, that is of 4 bit. Then this is the, next, this one, 00. 00 means 8 bit. 8 bit is in this particular type of service. Type of service, a differential service sometime. This is the type of service. TOS. How many bit? 8 bit. So how many symbol of hexadecimal? 2 symbol. Next, total length of 16 bit. This is of 16 bits. 16 bits means next how many symbol? 4 symbol. 4 symbols of this stream. What is the 4 symbol? 0054. Okay. Similarly, identification of 16 bit. 16 bit means 4 symbol. So this is identification. Okay. Then flag plus offset consists of 4 symbol. This is this one. This is the offset, flag and offset. Flag and offset. Okay. So similarly, next 8 bit of TTL. So this is TTL. Okay. Next protocol field of 8 bit. So 06 is in protocol field. Then header section. 16 bit. 16 bit means 4 symbol. This is checksum. Checksum. Okay. And next, 32 bit. 32 bit means how many symbol? 1, 2, 3, 4, 5, 6, 7, 8 symbol. 1, 2, 3, 4, 5, 6, 7, 8. This is the source IP. Source IP. And next, last, this 8 symbol is of destination IP. Destination IP. Okay. So we have to arrange in this format. Now we can answer. What is the header size? Okay. So what is the header size? So header size can be given from this one. H length field consists of 5, and this means this is in hexadecimal. Okay. So first we have to convert into decimal. So this 5 gives the 5 in decimal also. Decimal 5, and this is multiplied by the scaling factor 4, and this gives the 20. So 20 byte is the header size for this packet. How many byte? 20 byte. Because in decimal, this hexadecimal value of 5 is also same in decimal. That is the 5 multiplied by 4 scaling factor. This is the 20 byte size is the header size. Okay. So when header size is 20 byte, that is the minimum. So is there some data in option? No. Because if there is data some option, certainly the header size will be more than 20. Like 22, 23, 24, up to 60. But the header length is exactly 20 bytes. That means no option is there. No data in option is there. Okay. So that means option field is of 0 size. Okay. Is the packet fragmented? So from where we come to know packet is fragmented? We have the flag. If we come at this one, flag. Okay. This flag and offset all of 0, 0, 0, 0. That means first 3 bit of flag is also 0, 0, 0. This second is the DF, don't fragment field, and this value is 0. That means there is no fragmentation at all. And MF is also 0, more fragment. There is no fragmentation. Okay. So third answer will be, is the packet fragmented? Answer will be no. What is the header size? This is the 20 byte. Are any option? No. There is no option. There is no data in the option field. Okay. What is the size of data? That is very important. How to come to know the size of data? So size of data is equal to total length minus header length, right? Total length minus header length. Okay. So from where we come to know total length of the packet? So let me come at the data format. This is total length. What is the value? 0054. Okay. 0054. So how you come to know total length? Field is 0054. Right? 54. Yes. So convert it into decimal first. Okay. Convert it into decimal. So how much this will be in decimal? Yes. This 54 is a hexadecimal. So convert in decimal. What is the procedure? 54. That is the index is 0 and 1. So 16 into 5 into 16 for 1 plus 4 into 16 for 0. This is the process to convert any hexadecimal into decimal. So what will you be? This will be 80 plus 4. So this is the 84 into decimal. this 0054 give 84 in decimal. Okay, means total length is, now we can say that total length of datagram is 84 bytes. Okay, so data length will be total length minus header length. Header length is 20 bytes. We have calculated already. So what is the data length? 64 bytes. Okay. Data length will be 64 bytes. So here, what is the size of data? So data length will be 64 bytes. Okay. It is clear. So how many more router can be packet traveled? How many routers? Through how many routers the packet can be traveled? So this is given by the TTL information. So let's become at the TTL, time to live. This value is 20. 20 in hexadecimal. Okay. So we have to convert into decimal. So how to convert? We have to convert. So there is the index 0 and 1. Okay. So this will be 2 into 16 power 1 plus 0 into 16 power 0. So this will be 32. Okay, 16 to the 32. So actually TTL field consists of 32 in decimal. Okay. So what will be the answer? How many this packet, maximum how many routers can be traveled? So that will be the 32. Answer will be 32 because the value of time to live is 32. That means that packet can travel from source to destination by maximum 32 hops. Okay. Hops means router. So 32 routers can be traveled here. So answer will be 32. Okay. How many more routers? So this will be 32 more routers can be traveled. What is the identification number of the packet? So again we have to move to the data datagram frame header format. So we come to know this one. Identification have the 16 bit and that in this hexadecimal that is the 3. So this identification number of this packet is 3. Identification means all the fragments consist of the same identification number, so that receiver come to know that these fragments belong to the same packet, same datagram. Okay. Now, what is the source IP and what is the destination IP? So again, this is the source IP. This is in the hexadecimal. Okay. So we have to convert into decimal. This is also hexadecimal. We have to convert into decimal. So when we convert into decimal, dotted decimal notation, this give 124.78.3.2. And the destination address similarly give 180.14.15.2. Okay. So by this way, we can calculate the numericals or the data or the information that is based on this IPV4 datagram frame format. Okay. So Jai Hind.